Good morning, everyone. Let me navigate the stage here. I'll come this way. Okay, so I think you guys have heard like half of my presentation already, maybe. So that's good. Any PhD data scientists in the room? PhD, not PHP. Okay, good. The fewer the better. Okay, good morning. So my name is Jonathan Roeder. I'm a principal scientist at Adobe. It's a big fancy title. I draw boxes and tell people what to do, and maybe they listen, who knows. I work as part of the Data Solutions organization. This was founded at Magento after the acquisition by Adobe last year. Our job is to enable merchants and partners over time to create intelligent experiences, uncover commerce insights, a big part of what Ben was mentioning earlier, and do all this with data-fueled capabilities underneath. So exciting opportunities. Our responsibilities include Magento Business Intelligence. Anybody familiar with or use that? Know that? All right. Any kind of machine learning, AI capabilities. We'll be talking about that a lot today. And then also intelligent storefront search. So luckily, we don't have to do this alone. We have great partnerships at Adobe that we've been building. I'll call out a few. So first and foremost, Adobe Research. This is a large organization within Adobe, hundreds of research scientists, artists, engineers. They work in partnership with universities around the world, top universities, collaborating with them, publish cutting-edge research papers, and then also internally work to guess the future, iterate on the future, build the future, invent the future, and then connect that back to the product engineering organizations at Adobe and make it real. And so we work very closely with them, and we'll be exploring some of their research today. We also are fortunate to have a machine learning platform at Adobe that we call Sensei. This helps us with experimenting and productionalizing machine learning capabilities, which is actually fairly difficult. One of the advantages of working here is that we're not just walking the walk, we're talking the talk. So Adobe has been developing and delivering intelligent capabilities, AI capabilities, to production for some time. At Adobe, we kind of think about three big pillars of our business, our organizations. We have, of course, the creative side, Photoshop and everything else. And then our heritage in the document space and associated document cloud. And then last and certainly not least, our experience side of the house where we live in Magento. And so in each of these areas, you can see that there are a number of technologies that have been productionalized that are in use today across Adobe. And one of the really exciting things is some of these innovations occurring on one side of the house can be leveraged, used in another side. And so through our partnerships with research, et cetera, we get to look at those technologies, we see what makes sense, and we see how to make them real for our products. Okay, so there's a little bit about us, the royal we, and then maybe from here on out we can talk a little bit more about intelligent systems, AI, things like that. And then areas of research and focus and how we can make that real for commerce. And then we can talk about what we're doing today, what we've been doing for the last 6 months plus. Okay, so just to level set, so I mentioned intelligent systems, I mentioned AI. What am I really talking about? I'm talking mostly about machine learning. What's machine learning? I think we all have an intuitive understanding. Maybe people have explicit understanding or experience. Maybe I have a drum kit behind me. But anyway, machine learning is the capability of a machine to learn from experience without being explicitly programmed. That's a lot of words. The word learn there is really important, and the word experience are really important. If we dive a little deeper, and we will, we'll see that there are three main branches that I at least want to touch on today of machine learning. Subfields of supervised, unsupervised, and reinforcement learning. So we'll talk about them more, but really when you say the word learning, what does that mean, right? When you say the word experience, what does that mean? These are very human terms, and we have a lot of science fiction that we've read and watched, and we can think a lot about what our AI-driven overlord future will be. But for right now, everything that we're working on, everything that we're researching, it's really trying to get computers to be good at tasks without expecting them to have some fundamental understanding of what those things are. That's definitely science fiction, or at least Elon Musk companies. Okay, so let's dive in. Supervised learning. So here's an example of supervised learning. So let's say that we want to teach a machine how to identify a cat. In order to do that, we need to feed it data. We all know that AI is driven from data. But supervised learning requires that the data fed into the system is ground truth data, is examples of what you want the system to learn. If I want the system to learn how to recognize cats, I have to tell it what cats are. And then I have to tell it what not cats are. And I have to give it a number of examples. And then the learning comes in where the machine decides by itself, based on the algorithms used, which aspects of which picture are more cat-like and are more not cat-like. And so this can lead to millions or even billions of individual variables that the machine is learning to distinguish between cat and not cat. So that part's really exciting, but supervised learning comes at a cost. The cost is that you can't just feed in any data, you have to feed in data that's representative of the ground truth, and that data is hard to come by. We all have pictures of cats, but do we say cat for every picture we have? No, so there's human work, that goes into actually labeling all of these images before feeding them into the systems. There's a lot of technology at play today to try to automate some of this image generation or labeling. So for instance, if we have a picture of a cat, maybe we can perturb that picture in some way automatically. Maybe we can kind of 3D render it and shift it around, and then we suddenly have 10 pictures of a cat that we can train with the system. There's also a lot of research in how to reduce the amount of data that has to be fed in. In order for a system to be good at identifying cat, not cat, we need to send in lots and lots of pictures of cats. A human doesn't need lots of pictures of cats to be able to spot a new cat when it sees it. So there's a lot of research into reducing that cost. So let's compare this to unsupervised learning. With unsupervised learning systems, you don't have labeled data, you just have data, and you feed the data into the system, and the system can tell you certain things. But it's really just comparing the data. That's what it can do. So if you have a whole bunch of user data, like Ben was talking about before, you can do analysis and cluster those users into distinct groups. The machine can figure out what's unique or what's common amongst different groups. And it can be very, very insightful and granular in that way. You can feed in time series data and then detect anomalies. So these are exciting and powerful things that we can do with unsupervised data. But at the end of the day, it's a different class of problem than supervised problems. And the vast majority of AI that we're using, that you're using on your phone, et cetera, supervised today. Okay, so let's go a little deeper. Let's look into some areas of research. So natural language processing is about teaching machines how to understand what the hell we're saying, which turns out to be really hard. I was in Basel yesterday, and it's amazing. They speak 4 languages at once, and I have no idea what's going on. And so anyway, but these machines, in order to understand human language, we have to feed in. There's very active areas of study for having machines learn what humans are saying, and we have an entire research lab dedicated to that at Adobe. You've probably used machine translation before. In the last 10 years, that's gotten much better as we've applied deep learning techniques to that. Text summarization, I'll give an example of in a minute. And sentiment analysis, I think we have all heard of. So lots of interesting things here. So let's maybe apply it to commerce. We all have Siri or Google or Alexa. They're listening to what we say, at least hopefully when we want them to. And so there are many opportunities to, so as we have all these devices around us at all time, it's becoming more and more natural to interact with them that way. And of course, it'll become more and more natural to ask it questions like, would you buy me this? Can I get a blue one? So conversational commerce starts to come online. This puts a lot of pressure on these systems and then us to be able to understand what humans are saying. And this finally gets us around the corner from, if you think about classic search that we all do, when you very simply and tersely type what you're looking for, knowing that the machine can only understand a little bit. And if you switch over to a conversational mode, it gets easier and easier to be much more descriptive about what you want and to have higher expectation. So another example, if you're lucky enough to have a site that has a lot of product reviews on it, you offer these up to shoppers. Shoppers are looking at these reviews, deciding what they want to buy. This is great. But what if you have tons of reviews, right? And so it's up to the shopper to need to look through all these reviews to decide what to buy. Okay, so we've added features in the past such as sorting or filtering by rating or most helpful. We can even do sentiment analysis on the reviews to see if they're positive or negative. That's a form of natural language processing. But we have research that actually reads the reviews and then summarizes across reviews to get the gist of what different groups are saying, and then offer up those summaries to individuals. So we harness all that power, simplify it, and present it back to shoppers. So this is an area of research. Computer vision, of course, another huge area of focus. You could imagine at Adobe, especially on the creative side, but also on the experience side, how many images, how many videos we're helping to create, to produce, and how important computer vision is to our future. Common examples like the supervised problem I just mentioned before of cat and no cat. This is of course a computer vision scenario, but we also have optical character recognition, which is one of the original inventions of machine learning in the visual space, and then things like visual search. So let's dig in a little more here. Let's contextualize it to commerce. So let's say I have a product catalog. Let's say I have a set of images associated with each product. And let's say I want to automatically extract the colors of each image and attribute that onto the product so that we can automatically know what color our products are. Well, a naive approach to this would be to just sample all the colors in the image, very easy, and then you end up with these colors on the right. But this is obviously not the right answer because the background image, the background color is 65% of the image. So if we are contextual to commerce, then what we need to first do is identify what's the object of focus. And really it's a sub-object, right? So not only do we not care about the background, but in this case we don't care about the lady, sorry lady, and we don't care about her jacket. And that's not even a visual problem. That has more to do with like the context of the product itself, which might require natural language processing to understand. And so once we zero in on the shirt, then we can extract the color from there. So a lot of advanced work needs to be done in order to harness this in a way that's contextual to commerce. Another example, perhaps. Oh, two examples. Visual search. So just like we expect people to speak more and more to their machine, we also expect people to interact in a visual modality with their machines. So whether you're on Pinterest or on Instagram, whether you're walking around in the physical world, you're interacting with images all the time, you're taking pictures all the time, and so what if you're inspired by something and then want to see if that item is available or something like it is available? So visual search can detect the similarity between visual images and return relevant results associated with that. You can also be shopping a product and then view visually similar products in that regard. So this is definitely an area of research for us. Aesthetics. So let's say you have an experience that you're presenting to shoppers. You have a set of images, and let's say that you could modify those images based on what you knew about the shopper. Like, why do we view this as something that's static, right? So we can use machine learning to actually alter the images that we have. Let's take that a step further. So, maybe everyone's seen this before, but what do these images have in common? Anybody know? Anybody? They're faces. That's true. Okay. They're all fake. None of these are real. These are all generated by adversarial networks, machine learning, that has learned how to invent humans and cats. The motif of today is cats, because we're talking about machine learning. And so deep fakes, this concept of generating something that fools us, it's alive in the wild today. It's very interesting. So whether it's images or audio, so someone could emulate my voice if for some reason they wanted to do that, or even videos now. So generating, obviously we see this in all the Marvel movies, but generating things that can fool us. This is an area not necessarily of research at Adobe, but certainly something that we see. Okay, so what do we just look at, right? So let's contextualize this a little bit. On the one hand, a lot of our research is focused on interacting with people the way they naturally interact, understanding what people say and understanding what people see, and helping to bridge that understanding into machinery, and then helping to provide intelligent experiences based off that. And then on the other side, we have opportunity to understand from a merchant standpoint, obviously video, text, etc. But we could even harness content to create new content, like the ratings and reviews example, and even generate content, right? So we could generate images, we can generate product imagery, or even videos, without necessarily going through a production cycle. Don't tell our creative cloud friends, but of course that's part of what they're working on as well. But there's interesting opportunity on how to engage with shoppers on their terms and the way they want to interact, and then enable merchants to generate experiences that are potentially individualized to those shoppers. Okay, so let's keep going a little bit. I'm sure you've all heard of, used traditional A/B testing. So if you have some experience you want to test, you provide a test with an A and a B. You run it for some length of time. You see which one's the winner. You see if there's some statistical relevance to which experience is the best, and then you make a decision to then roll that out as the only choice. So a few problems with this. You have to have a lot of a relevant amount of traffic, and you have to run these tests for long enough time to collect data. And it could be that the tests are fairly even, or it could be one experience is superior to the other to the point that you're losing money on the alternate experience. So machine learning systems, multi-arm bandits, have been around for quite some time and are being used as part of A/B tests to add more intelligence to the testing experience, to reduce the amount of data traffic required, and then to optimize very quickly towards the winning result. And so in that way, you can more finely tune what's going on and not leave as much money on the table. Contextual bandits are exciting because maybe there's no one answer for the test. Maybe the answer for you is different than the answer for you. And so contextual bandits can optimize for the individual. These are baby steps into the last branch of machine learning we'll talk about today, or the second to last, of reinforcement learning. So reinforcement learning, you might have heard about or know, this is the core capability that's used for self-driving cars. It's also what's used for the systems that you've heard about that can now win various video games against human players. These systems focus on optimizing for a goal over a long period of time. So they're very different than supervised and unsupervised systems. And what's interesting about them is that's kind of what we do with commerce, right? We try to optimize for a long-term goal. We try to provide a shopping experience to optimize for customer lifetime value, right? And so we think that there's a lot of applicability of that into commerce. We actually have research into causal modeling. So when we think about machine learning, we think a lot about correlation. We think about data and having some understanding and learning something and then applying that. But we don't necessarily know the cause of something. We know the correlation, we don't know the cause. Causal modeling is a very active area of research for us, very early, but if we could actually understand A plus B equals C, and then we could start to model for that as well. That gets us into a final future area of simulation. So if we can understand better why things happen, we can simulate these experiences without having to test them online. So if you want to know when you should launch a promotion, a discount, make a site change, you have to experiment and try and see how these things work today. But if we can model enough of this in the future, you could experiment virtually in simulation and then get a good idea of what will work. Pretty advanced. Not showing up in production anytime soon, but certainly an area of research. But if we model the world and how it works, we still need to model humans, right? So right now, that's one part that's left out of the equation. Certainly we're pulling in all the signal data for humans, but we're not necessarily accounting for all of our peculiarities. That'll haunt me later. So what do I mean by this? I mean that we all have cognitive biases. We all have blind spots. We all have ways in which we think that certainly mathematical models aren't built today to predict. Let me give you an example. So this curve here is just showing very simply, that how we would think to model mathematically winning $100 or losing $100, right? If you were gambling, but maybe to you, winning $100 doesn't give you as much joy as losing $100 causes you sorrow, right? So if those things aren't equal, and machines don't know that, and then really don't know you in particular, then how can they actually try to optimize experiences for you? So a lot of interesting research happening at Adobe here. Okay, so really the pitch is that this all builds towards a future where we have a self-generating, self-optimizing experience for all the users that we engage with. That's a lot, and that's very long-term, and none of it's for certain, but it's very exciting to work at a place that's researching all of this. Okay, so bringing it back down to the now, Magento recommendations. Let me see, I think I have a few minutes. I have a few minutes to talk about the now. Okay, so today in Magento, you can certainly configure related products, cross-sells, upsells. There are manual relationships, there are rule-driven relationships that you can create, and of course we have an ecosystem that supports different types. But we know, and as consumers, as people who spend a lot of time online, if you look across these main areas where we spend time online, I think these numbers are from the US, but you can see that the more advanced capabilities that these leaders provide are all personalized. So we're all getting used to personalized experiences. We're all expecting it. If you look at the stat there a second ago, you can see that Amazon, around 35% of purchases are driven through product recommendations, which is huge. And I think we as consumers all expect product recommendations. Makes sense. We expect them to be intelligent and relevant to us. So in order to achieve something like this, what do we need to do? Well, we need product data, we need the catalog, we need all the user behavior. We need to understand what people are searching on, what they're clicking on, what's in their cart, what they're actually buying. And then we need to be able to harness all that data using the machine learning algorithms we've been talking about, in this particular case, recommender systems, in order to build up these product relationships. So at Imagine earlier this year, we announced that we're working on and bringing to market Magento product recommendations powered by Adobe Sensei. So the core goal is to provide contextually relevant recommendations to shoppers in key areas of the shopping experience and deliver this as a software as a service capability integrated with Magento Commerce. Under the hood, oh, do I need to go back? I'll do it. I'll do it for you, Ben.
Just like that. There we go.
All right, good. Good pictures. Never mind. No regrets. All right, no regrets. Under the hood. Okay, so under the hood, Might be hard to see here. On the Magento Commerce installation, we have a storefront tracking and serving layer that will send events as shoppers shop. We have a catalog sync system that will synchronize the Magento catalog into the SaaS environment in real time as things change. And then on the receiving side, on the SaaS layer, we have a data lake, a data processing engine, one of those data lakes, Ben, that you got to step over. And we have a machine learning infrastructure that will automatically calculate new machine learning models based off of all this data, and then provide them as SaaS services for real-time recommendation. So this is what we're working on. We've been working on it for some time. We have some early adopter customers that are participating very early, where we've been receiving and filling a data lake full of data and using that to build and harness and hone our machine learning models and our recommendation system. This is really just the start for us. With more data, we can do more research in conjunction with our merchants, and then we can deliver more capability, which is certainly which is our charter. Okay. So with that, I'll stop, and we have time for questions.
I'll shoot the first one.
Oh no!
It looks quite amazing what you presented here, Jonathan.
Some of it might even be true.
Yeah, of course. The last part with the reinforcement might be something that we're still looking upon to see applications in real projects and real life Magento instances. But regarding the first two side projects that you mentioned, the machine learning and the other one, it looks quite interesting for applicability in today's e-commerce, I think.
Mm-hmm.
And as you mentioned, you are, I think so, that you are kind of laying the pillars of what would the next product of Magento's improvement as an Adobe part of the company would be or would look like in the future. Are you following up on a path that would allow products from Adobe to be merging, let's say, the backend of the Magento instance, so that users or merchants can fully use Adobe's power while managing their stores?
Yes. So there are efforts to do that. Those include things that I'm not sure I'm allowed to talk about in public yet.
Off the record.
Okay. Everyone turn their Twitter off. Sure. So yes, the short answer is yes. Let me circle back and see if I can mention one of them in public. But the idea is to provide capability in Magento back into Adobe services. You can imagine around video, imagery, things like that, to harness for their storefront experiences. And that's just one example. So there are quite a few.
Because merchants are used to using some of other tools to further improve their, let's say, stores, and obviously using some external tools might create some friction or create a risk within the project and so on. So I would assume using the same very project that was working on from the beginning, as is Adobe Sensei now for Magento, would be easier to adopt as an onboarding process.
That's certainly our goal, is as we identify and develop integrations, that they should be as seamless as possible.
So do you have a community to identify these features, or we should start up our own Meet Adobe association?
Meet Adobe. Let's talk about that offline.
Okay. Okay. Any questions from Jonathan? If not, we'll have a 30 minutes break. And after that, we'll meet up here at 12 for the dev track and downstairs for the business track. Make sure you get there, everyone who's on the business track. The stairs are across the registration. You just go down one level, and then on the right, you should see the screens and the Meet Magento logo. So
I think we had one question.
Oh, sorry, one question?
I almost got away.
Well, it was a shorthand.
Hi. Actually, the Magento recommendation sounds pretty cool. And I wanted to know if you can share with us some results from the early adopters, because we have Amazon Personalized, we have Google Recommendations AI, and they already shared their results. And I was curious what Magento recommendation is offering.
So results as far as feature set, or like how well the recommendations are working? How well? Okay. So right now, the phase that we're at is it's when I say early adopter, I think I need to be careful. The phase that we're at is we've identified and working with partners that are merchants that are sending us data, and we're in the process of building those systems. So they're not yet using recommendations live in production. So as that comes online, we'd love to share more, but that'll be a while. I think we might have an announcement soon at another conference. Okay.
I have another question.
One more.
Any plans to also make an open data strategy, like the open source, what drove Magento to grow? Data is a big problem for developers to tackle this kind of problems. And most of this data is closed in analytics. We don't have access to data.
Yeah,
actually.
Yeah, no, great question. And number one, I mean, I think, like I was trying to say at the beginning, having access to data to build these systems is incredibly important. And we see that we need to figure out how to empower our ecosystem so that it's not just us collecting data and building these systems on our own. Having said that, of course, there's also the complication of it's not our data to share necessarily, it's our merchant data, and it's the in-shopper data and all the rules and regulations that we all deal with there. So there are some things that we're very excited about around an open source project that we have that allows for any storefront data to be tagged and can be shipped anywhere. Let me tell you more about it after. Anyone's interested, come and find me. And then we want to explore ways to further that. It might be that we can only ever share data with the developer community as individual merchants allow it, but these are things that we're trying to work through and figure out.
Great. Thank you, Jonathan, for your presentation. Thank you for being in Romania, I think for the first time.